Hello everyone, and welcome back to the Fluctus Channel. Newport News Shipbuilding in Virginia is one of the most important carrier yards in the world because every nuclear-powered aircraft carrier currently serving the United States Navy was built there. The yard belongs to Huntington Ingalls Industries and contains huge dry docks, cranes, fabrication shops, outfitting piers, and teams skilled in nuclear propulsion, steel assembly, electrical integration, and carrier testing. A supercarrier begins as thousands of separate parts. Steel plates are cut, shaped, welded into modules, and joined into larger sections. Pipes, cables, ventilation, tanks, machinery, and electronics are installed before many sections are lifted into place. On Ford-class carriers, this modular method reduces work later inside tight compartments. The finished ship is more than 1,100 feet long, displaces about 100,000 tons, and is powered by 2 nuclear reactors. USS Gerald R. Ford, CVN-78, introduced the class. It carries new systems such as electromagnetic aircraft launch equipment, advanced arresting gear, improved weapons elevators, and redesigned spaces intended to support faster flight operations with fewer sailors than previous Nimitz-class carriers. The ship honors President Gerald R. Ford, who served in the Navy during World War II aboard the light carrier Monterey. The class continues with John F. Kennedy, CVN-79, and Enterprise, CVN-80. Kennedy was built at Newport News as the second Ford-class carrier. Enterprise continues a famous Navy name carried by earlier warships, including the world's first nuclear-powered aircraft carrier, CVN-65. These ships are not produced quickly. A carrier requires years of construction, testing, corrections, and crew training before it joins the fleet. One of the most dramatic moments is dry dock flooding. Before the ship can float, workers clear the dock, secure loose equipment, test watertight boundaries, and inspect openings. Pumps and valves are prepared, and water is allowed to enter slowly. The dry dock that once surrounded the ship with concrete begins turning into a controlled basin. As the water rises, engineers monitor the hull, mooring lines, draft marks, and stability. The carrier does not simply lift free and sail away. It must float evenly, with thousands of tons balanced correctly. Teams check that no unexpected flooding occurs inside compartments. Divers and inspectors may examine areas below the waterline. When the ship is stable, tugboats and line handlers prepare for movement. Launching or undocking a giant carrier is slow choreography. Tugboats push and pull at carefully selected points, while pilots, shipyard personnel, and bridge teams coordinate through radios. Lines are shifted, clearances are watched, and the massive hull moves out of the dock inches at a time. Once clear, the carrier can be guided toward an outfitting pier, where years of additional work may still remain. Testing continues long after flooding. On John F. Kennedy, deadload launches tested the electromagnetic catapult system without aircraft. Heavy-wheeled test loads are attached to the shuttle. The launch sequence is checked, and the system fires the load down the deck into the water. Engineers study acceleration, energy settings, software behavior, and recovery procedures. These tests prove the catapult can deliver controlled power before pilots risk aircraft on it. Workers also prepare the ship's future operating environment before flooding begins at full scale. Temporary lighting, scaffolding, hoses, and access platforms are removed or secured. Compartments that will later hold sailors are checked for watertight fittings, while engineers confirm that valves, sea chests, and hull openings are closed correctly. The operation may look ceremonial from outside, but inside the yard it is treated as a major engineering test. Ford-class construction also includes coordination with the future crew. Sailors assigned to the pre-commissioning unit study launch systems, arresting gear, propulsion spaces, navigation equipment, and emergency procedures, while shipbuilders keep installing and testing hardware. This partnership shortens the gap between construction and fleet service, because a carrier is not just steel, it is a working city at sea. A carrier rolling out of dry dock therefore marks progress, not completion. The hull has become a ship, but the combat system, flight deck, habitability spaces, elevators, propulsion plant, and crew procedures must still mature. Newport News turns raw steel into national power, but the sea decides whether that power is ready. Once a carrier or amphibious ship leaves the yard, the ocean introduces risks no shipbuilder can remove completely. Fire is among the most dangerous. Fuel, electrical cables, lubricants, paint, ammunition, hot machinery, and aircraft operations can turn a small flame into a ship-wide emergency. That is why sailors train constantly. During fire training, hose teams dress in protective gear, connect to the fire main system, check pressure, and move toward the simulated casualty. One sailor controls the nozzle, another supports the hose, and others manage corners, doors, and communications. Boundary teams check nearby compartments for heat, while repair lockers track equipment and reports. General quarters is the larger alarm that sends the entire crew to battle stations. Passageways become controlled routes. Watertight doors and hatches are set. Damage control teams prepare tools. Medical crews stand by. And watchstanders report conditions. The drill tests whether thousands of sailors can shift from routine work to full defensive posture quickly.
Quarters, general quarters. All hands man your battle stations. Set atmospheric conditions zero throughout the ship.
Chemical, biological, and radiological drills add another layer.
This is the only ship I've ever seen where medical has a...
Sailors aboard ships such as USS Essex have practiced responding to contamination threats by setting protective conditions, controlling movement, and testing detection procedures. If a CBR attack or contamination event occurred, the ship would need to limit exposure while preserving propulsion, communications, and fighting ability. Countermeasure washdown systems help protect exterior surfaces. Nozzles and sprinklers spray seawater across decks, bulkheads, and equipment, washing away or diluting contaminants. USS Higgins tested such equipment while operating in the Philippine Sea, and aircraft carriers such as USS Ronald Reagan have used similar washdown practices. Salt water can reduce some surface contamination and physically remove particles, but it can also accelerate corrosion, so crews must later inspect and maintain affected equipment. Washdown is not a magic shield. It reduces exposure while the ship maneuvers or prepares cleanup. After the spray stops, sailors may check sample points, mark contaminated areas, and avoid tracking residue below deck. Equipment exposed to seawater is rinsed, dried, lubricated, or inspected, so protection against one hazard does not create corrosion problems. Individual protection matters too. Mission-oriented protective posture gear includes masks, gloves, overboots, and protective suits. MOPP fitting ensures sailors receive equipment that seals correctly. Training teaches them to dress quickly, avoid touching contaminated surfaces, and move through controlled areas without spreading hazards. CBRN exercises with Marines and sailors build the same habits under pressure. Personnel establish clean and dirty zones, monitor each other for contamination, and practice decontamination steps. During disease outbreaks, cleaning becomes just as important. USS Theodore Roosevelt conducted sanitizing operations during the COVID-19 crisis. With sailors wiping surfaces, controlling movement, and trying to reduce transmission aboard a crowded carrier. A warship survives because the crew prepares for the worst while doing ordinary work. The same sailors who launch aircraft, cook meals, maintain engines, and stand watch may suddenly become firefighters, medics, contamination control teams, and damage control specialists. At sea, there is no fire department over the horizon. The ship's crew is the emergency service, and every drill buys time when danger becomes real. Aircraft face similar contamination problems, especially when they must move people, cargo, or medical patients through a global airlift system. Infectious disease can spread inside cabins, cargo compartments, vehicles, and medical equipment if crews do not control airflow, surfaces, and patient movement. COVID-19 forced the military to develop rapid methods for transporting infected personnel while protecting air crews. One solution was the negatively pressurized Connex, or NPC. Built around a container-like module, the system creates negative pressure, so air flows into the enclosure rather than leaking outward. Filtration removes dangerous particles before air is exhausted. The concept allows infectious patients to be treated and transported aboard aircraft, such as the C-17, while reducing exposure risk for crew members outside the module. During flight testing, the NPC was loaded into the aircraft, secured to the floor, connected to power, and checked for pressure, airflow, communications, and medical access. Evaluators studied whether the system remained stable during taxi, takeoff, turbulence, and landing. Medical teams practiced entering, treating, and monitoring patients while wearing protective equipment. Aircrew also trained for chemical and biological environments with MOPP gear. Before missions, personnel inspect masks, filters, gloves, overboots, and suits. Instructors check fit and movement because a crew member must still operate radios, checklists, cargo locks, and emergency equipment while protected. Heat stress, limited visibility, and reduced dexterity all become real problems. Contamination control area training teaches units how to move from dirty zones to clean zones. At a fighter wing, personnel may establish entry control points, mark lanes, collect contaminated gear, and perform checks before people re-enter protected spaces. The goal is to stop contamination from traveling with the person. Aircraft decontamination is even more demanding. During exercises such as Steel Night, Marines and aviation crews practice washing and wiping aircraft after exposure. Teams wear protective gear, approach in order, apply cleaning solution or water, scrub surfaces, and pay attention to intakes, landing gear, panels, handles, and crew entry points. Runoff must be controlled, and sensitive equipment must not be damaged. These procedures are slow, hot, and exhausting, but they keep aircraft available. From Newport News dry docks to Navy washdown systems and Air Force biocontainment modules, the story is one of preparation before disaster. Supercarriers are built in giant basins, but they remain useful only because sailors and airmen know how to protect them from fire, contamination, disease, and damage. Rolling a carrier out of dry dock is the beginning. Keeping ships and aircraft ready after that requires constant training, testing, cleaning, and discipline. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.